Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to everyone. Welcome. My name is Siti Haja Omar. I'm a project
Recording in progress.
Alam Bina Senda Berhad, and your moderator today for our second design lecture series 2022. And today is 21st September. And we hope everybody in a good health. And today, PAM series has invited a very wonderful and talented architects all the way from the Lion City, Singapore. It's a pleasure for me to introduce to you Mr. Aloysius Lian. I hope you're online. Hi. Hi. I hope everything fine in Singapore.
Yes,
Is that clear?
Yeah.
Okay. All right. So before we start, let me give some introduction about our speaker today. Mr. Aloysius Lian is a registered architect in Singapore and has practiced and taught architecture in the United States and Singapore, and graduate from Pratt Institute with a Master of Architecture. Mr. Aloysius has won various awards for his outstanding projects, such as the Future of Us Exhibition Pavilion and the Hotel Fort Canning project. And with the topic computational design for sustainability, we hope everyone is eager to dive into the lecture today and ensure to get your coffee ready. Okay, so if you have any question, please key in the question in the question section. We will read through, and our speaker will answer your question during the Q&A session. And in the beginning, we will give you this sign in code for you to key in, and then sign out code will be towards the end. Okay, Mr. Aloysius, is it okay for you?
Yes.
And yeah, the screen is
I'll
yours.
share screen.
Over to you. Yeah.
Okay. So hi everybody, can you see my screen already?
Yes. Okay.
Yes. Okay. Thank you for having me, and thank you for the invitation. So let me just go right ahead. So essentially, I'll just summarize very quickly so that it's not very long-winded. We're trying to show how you can use computational design for sustainability. Basically, from a wide range of projects, from large scale to medium scale, and then even to a much smaller furniture scale. Okay, so this is a brief introduction. CT has already done a very nice introduction. But these are introduction in terms of images. So what I was referring to is the large scale, which is this pavilion in front of the Marina Bay Sands, and to the medium scale, smaller scale, which is residential houses, and even to lighting installations, as well as to furniture that you see over here. This is like a table. Okay. So how this talk will be is more of like a dialogue, I hope so, is to talk about why we want to go towards computational design, how we can use computational design tools for complex fabrication, and also to validate our designs using evidence-based design. This is to prove that whatever sustainable principles that we are designing for is really working. Using these complex fabrication tools does not necessarily mean that you have to build something very fanciful. So that's where you can apply these techniques for efficient fabrication and installation. And of course, if you talk about this, like some of the talks that I attended are also from Malaysian architect Siksan, right? A lot of architects work for top 5% of the society. So you have bespoke fabrication for luxury. But what we also want to be able to use this kind of techniques is also for the masses, especially students. Okay. So let me just begin with like how I experienced computational design from a young student. So this is a little project that I worked on as a student intern when I was studying in the States at Pratt. So that my school is in New York, so I was very fortunate to intern for Dean Mox Architects. So Dean Mox is a very good friend of Shigeru Ban. So he's like the local architect whenever Shigeru Ban has commissions in the US. So he was commissioned to do the Aspen Art Museum. And this is the final built product. I was involved only in the very beginning, but this is just to tell you how you can start small. So the initial design concepts were based off on these wood models that I did a very simple digital mock-up. So again, these are the wood models to show how we could have a play of light and shadow within the gallery space. And what you see in the previous slide here was what I have modeled using computational design tools so that I can vary the sizes, the spacing. And then across the pond at the Atlantic, right, in Germany, where Shigeru Ban was based at that time, is another German intern. So this German intern was translating all my digital models into a physical model because Shigeru Ban still wants to see the actual physical and tactile nature of the model before moving on in his design phase. So this is the German intern here carrying up the model to test the sun shading that you see at the bottom right. And again, these are some of the diagrams that I was helping out with. So this intrigued me in the way that you could use this kind of digital design techniques to be able to develop and validate your design, as well as how you can really make your life much easier. Another sample of how we could add more complexity. So this is a sandwich interface between two lattices and a three-dimensional truss. And this is the final build product. So I was just like an intern, so I was only involved in the initial design process. This one was done by the actual project architect. Okay, then after I have graduated from school in New York, doing my first project in Brooklyn. So essentially, this is a beer garden. This beer garden is done, again, designed with computational techniques, but in a old school way. So what happened was that this project was in 2008, before the robotic techniques of bricklaying as done by the Block Research Group in ETH. So what we have come up with was a very simple system whereby we came up with plan drawings, and these plan drawings would show the bricklayer how to lay each brick layer by layer. And that's how they came up with the final product. When I came back from the States, I worked in DP Architects for a while, doing some hospitality projects. After that, I went to do research again for SUTD, Singapore University of Technology and Design. So this was one of the first few things that I worked on when I was working as a researcher. We joined this Singapore Institute of Architects competition, and luckily we won. So this pavilion is meant to be an idea about parametric design that is meant for 3D printing. So this system that we have developed essentially tries to create a pattern density that efficiently redistributes interior daylighting conditions using a lattice roof-like structure. Okay, and we did analog as well as a digital test in which we would try to optimize the path in which you can walk through whilst having different kind of daylighting conditions. And then we compare different options of how we can lay out these modules. But the important thing is that this particular project allowed us to develop this script. So this script, computer script algorithm, helps us to create this kind of filigree of design patterning that we wanted to try to test out as a physical prototype. So as part of the Advanced Architecture Laboratory headed by Professor Thomas Schoeffer, we were invited to come up with an exhibition at the Singapore National Design Centre. And we explored the idea of translating what we have as a 3D printing concept into an actual built physical laser cut concept. So what you see here are aluminum panels that are cut. They are not powder coated yet. And we did it in a quite brute force way, as you can see here. So again, a lot of student involvement. What we were doing is we developed the way in which we could generate the two-dimensional cut sheets and optimize the amount of cut sheets within a particular normal 6 by 8 feet metal sheet. So we had to try to bend these elements together, and then we riveted every single one of them. So it was quite time consuming. But we were very lucky. It's like being at the right place at the right time, because during this exhibition, there was a member of the ministry who were trying to look for ideas for Singapore's SG50 celebrations, which was in 2015. So they wanted to find like a kind of a structure to connect between the three exhibition domes that are supposed to showcase what Singapore has as a vision for the next 50 years. And they kind of liked the design that we have. And this resulted in us being able to be a part of this project. Again, it's part of SUTD Advanced Architecture Laboratory. This is right in front of the Marina Bay Sands. I think a lot of you who come over across for shopping and gambling, you will be quite familiar with it. Then this is another view of the pavilion after the exhibition is over. However, it's quite different now, which I will show in our subsequent slides later on. It's quite a large span structure. So essentially maybe around like 4 football fields and a large span of 20 over meters. It consists of 13,000 unique panels that are laser cut. And the interesting thing is that it's a regional effort. So the laser cut panels were cut in China. The structure was rolled in Vietnam. We did the actual physical prototype as an arch in Vietnam. And then after it was assembled, it was disassembled and shipped and reassembled in Singapore. So what you see here is kind of like the design concept for how we have come up with this pavilion. So at the top left-hand corner is where you see our overlay of wind analysis as well as solar analysis. The location of the pavilion is at the Marina Bay, which has quite high wind speeds due to the proximity to the sea. So there were a bit of wind tunnel testing that we have to do using a physical prototype and working with the professional engineer. And we wanted to make use of this wind study, both digitally as well as the solar analysis. So this determines the filigree of our patterns over here. And in a nutshell, right, what you see here are that there is a structural system. We clad over the structural system, again in a sandwich panel. So these sandwich panels are laser cut aluminum panels that sort of conceal the structure that's going underneath. Okay. So we worked with a very good engineer, Passage Project Yasin, who was able to rationalize our design concept and make it structurally efficient. The good thing about the application of computational design is that even though this is a very complex project, we were able to communicate using a Grasshopper script file that was very small in size. So if you were to do this, say, for example, in a simple modeling program that you are familiar with, like SketchUp or Revit, right? It would have taken up maybe hundreds of megabytes, maybe even 1 gig. But this Grasshopper file is only a few megabytes because essentially it just carries the information for the orientations of the panels and where the structural lines will lead towards the forces below. To understand again how this structural system is a very straightforward design. We have three main arches that you see here. There are three main arches. These are the three main arches. And the only thing that acts as a grid shell is this particular portion in the center. Later, when I share with you the construction photos, you will know what it's about. Let me just clear. And if we were given more time, it would have been better if we can design it as a total grid shell. But the entire process from the time that we approach, as I mentioned, right, we approach after we did the exhibition to the final opening was only 6 months. And our design process just took maybe not more than 6 weeks. And that's the beauty of having computational design. And that's why I wanted to show you this preliminary design concept. So again, for passage projects, we wanted to try to see whether we could do multi-angle welding. But again, that came with a bit of resistance, because this was also meant to be kind of like a design and build project. So at the end, we developed a system whereby we will do a very simple self-tapping screw detail. The panels are all bent in this portion over here, and then it's affixed to the purlins that are going over the actual structure. So you can see here, this is the structural concept model that is from Passage Projects. And now we talk about the actual realization of the patterning. Okay, so this is how it looks like in Rhino, the software. And this is the generated panelization. If you notice, if you look clearly, there will be 2 numbers at the 3 corners. So the first number shows the patterning for the top layer. The second number shows the patterning for the bottom layer. So this numbering will detect the amount of patterning that will be applied to each of the panels. And you can see here there are varying degree of complexity to the paneling based off on this logic system. And this is how it's applied as a gradient. But in actual realization, right, on the facade itself, it's not so clean. It's not like a beautiful gradient that you see here, but more reacting towards the amount of sunlight and wind that we want to pass through. This is a 3-dimensional representation. And then again, like what I was explaining to you, we have it as a labeled mesh. And this mesh will determine the complexity of the panels. Okay, so all of these drawings that you see here, right, are not self-drawn. We didn't have to draw it. It was done by the computer using Python as a scripting language. These are the fabrication in-process photos that you see over here. So these are the self-tapping screws. This one is the little smaller pavilion. You can also see that each of the panels are protectively wrapped, and they have a labeling system. This is the showing of the rivets. So kind of like the similar concept to what we have done in the earlier exhibition. But there's another one that you see here that are with the self-tapping screw. So this channel angles, right, helps to solve the double curvature to provide for construction tolerances. And as I've said, this is the mini portion of the whole pavilion. And this is the pavilion during construction. So as I mentioned, right, essentially this is one arch and there's another arch here. So whatever that is behind here, that's the actual grid shell. So we needed all this construction staging to ensure that the middle portion of the pavilion is supported while the arches are constructed in place. Only then can we release all the staging and let the shell in the middle sit on the respective three arches that are around it. Okay. And this is the pavilion after it has finished its purpose, which was for the SG50 celebrations. They have repurposed it as part of the Gardens by the Bay. So this thing that you see here is an exhibition where the exhibition space where they have periodic festivals that you see here. This is a post-COVID, pre-COVID photo. And this is a photo of it now, recently. They have some lighting shows here that can make use of our design here. It's also widely used as an Instagram place, you know, or for weddings now at the moment. So you can see nice shadows here. It's very windy, so it's kind of like a artificial canopy, so to say, a canopy that doesn't shed leaves. So it's very practical. Okay, so this is my own project when I have my own practice. So we use the same kind of algorithm, right, that we have for this very complex thing, but for a very simple project. So essentially, this is again part of, we use concepts of having bent aluminum panels, laser cutting, and prefabrication and ease of assembly. So again, this set of drawings are generated by the computer. We will not need to have any like manual drafting. This is how it's assembled. So very simple system, bolted, and then we have this detail to adapt to the construction tolerances. Because this is a A&A project, the building facade already existed. So again, a modular system, we have a grid, and then we will hang that particular module over to this grid, this subframe grid. This is the initial render for the client, and then we will show you the end built product later on. So this is a prototype that we did. What we wanted to be able to achieve is like a nice relief, and yet we want to make sure that there is no areas where the water will trap. So the maximum protrusion is reduced so as not to create any water accumulation for prevention of dengue, because this is the area is there's a lot of dengue. Okay, we make use of the same detailing that we have learned from I have learned from the Future of Us project to ensure that these corners will not clash, especially during installation. So this whole project was assembled in less than half a day. The prefabrication took 2 weeks, and most of the time was actually for the powder coating, because laser cutting is a very fast and efficient way of construction. Okay, and this is the final build product, which is very similar to the rendering. Okay, and since we are talking about in this middle scale, we also want to share with you how you can use this kind of computational design techniques to be able to apply to landed housing as well. So what we do in our practice is that we have this environmental logging, in particular especially for A&A or reconstruction projects where we maintain most of the house. We would try to log the existing environmental conditions. So this is to provide a very site-specific understanding of the project, because a lot of times, in fact, most of the times when architects design, we will just use the prevalent wind direction that is like from north to south, and then the east-west orientation for the sun. But this may not be the case in Singapore, because sometimes in landed houses, neighborhoods, we are very close to our public housing, the HDBs. So these HDBs do cast a shadow onto those lower houses. And in particular, some areas, they even create like a wind tunnel effect because of the way in which the neighborhood is shaped. So it's very important to have this in mind when we design. And we not only do we do an initial study, we will validate before and after to try to see whether whatever design concepts that we're trying to sell to the client really works. So this is one case study which has been completed. It's a house at Totak. So we try to design it in such a way that, because even though the existing house here is has very little natural wind to begin with, and it's really surrounded by a lot of landed houses, we have this central courtyard in which we make the central courtyard hotter than the rest of the house. So this would create a kind of like a stack effect where the air is drawn in through here. The windows that you see here are closed, but when the house is occupied, most of the time, the elderly couple, they will keep all their windows open. And this actually draws in the air upwards through this courtyard that you see here. Okay. This is a real factual validation. As I said, we have to be completely frank. The sensors don't lie. So what we have done is this design did slightly improve the natural daylighting levels. But of course, the temperatures, optimal temperature, it did not succeed. It's still very hot. Because Singapore is very hot, right? We are in the tropical area. And as I mentioned, the client actually doesn't really use a lot of air conditioning. Okay. So that's why you can see the humidity as well as the temperature are much higher than the optimal. But that's the whole point. We try to learn from the designs that we have done rather than just always repeating the same thing. So with this lesson learned, we can apply it to other houses. Now we go back to a slightly bigger scale. This is for Ling Bridge. And why I want to share this project is just to let you all know, we have shown you how computational design can be used for very complex patterns, like the 13,000 unique panels for the pavilion. This Ling Bridge is a very simple, straightforward Ling Bridge at the downtown area of Singapore at Robinson Road. So this is our client. He owns 71 Robinson Road. He wants to connect to this building over here. But his main point is he wants it to look nice and it must be super fast, because he needs to obtain the CSC as part, he needs to complete this Ling Bridge as part of the agreement with the government to complete the development of his building. So the design process again was very fast. To him, it's very straightforward. He just wanted to blend in something that looks like it belongs to his building and yet blends in with the immediate neighbor. So we came up with a few design proposals. This was the initial one. And the good thing about having computational design is that it allows us to play around and have many experiments with the design intent. So we could overlay any image that we want, and it will create a customized perforations on the panels itself. So this drawing itself is also generated from Rhino straight and ready for submission to the authorities. This is a 3D view of this. This one is manually modeled. because we wanted to make sure to explain to the contractor how the detailing is like. So essentially, again, it's a very simple, straightforward design for fabrication, because the whole process, we wanted it to be super fast, because it's also a very well-trafficked road. We only have like 2 nights to complete the entire construction. So these are the panels during fabrication, and we worked with the fabricator. For this particular project, instead of using laser cutting, we used the custom punch hole. So we were working with 5 different radiuses of the holes to be able to create the end effect that we want. So this is like the first night. First night is just to hoist all these beams over and then do the casting. First and second nights are to hoist the beams over, and then after that we will be able to cast over this portion. And the rest of it is just cladding. So as you have seen from the landed residential project, it was done in half a day, but that's because it could be done in the day. This one, we tried to do this portion here at night. And again, it took just a few nights to clad this particular areas together with all the defects managing. Okay, and this is the final build product. So again, a very true translation from the artist's impression to the final build product. So again, something like this. Okay, so this is an actual photo. So you have 5 different kinds of radius of the circles. So entire construction process, if you count not in terms of the overall timeline, but in terms of the days on site, is a week and a half. Okay, so then now we go back to the smaller scale. So how can we use this technique responsibly for doing a luxurious marble table? So we were commissioned to do this as part of a Singapore furniture and design event, whereby we have to go along with the curatorial direction of unnatural phenomena. And we were matchmade with a marble supplier. So we talked with the marble supplier. They have a very cool method of bending the marble. It's called Gallery, this marble supplier. And this technique is very useful because it allows us to create many designs. And in order to make this design process less prescriptive, we came up with this little script that has these 3 determining factors: how fast you can build this furniture, and the material efficiency, as well as the structural stability. And all those that you saw over there are generations of it, created by the computer algorithm. And by using bending instead of carving, you are able to create a more sustainable product, because you're not wasting product through chiseling away all of the materials. What you saw earlier were some images of it during construction. So the actual base is made out of rattan, and then after that they plaster over and they bend the marble over that. So these are the images of the construction, the design process. Again, so these are all not done prescriptively. You can put in certain requirements and it will generate different options based off on this. So technically, you can also see that there are 2 curves here. If it's supposed, if we are to design for another purpose, instead of like this is meant to be like a little study table. If it's meant for a dining table, you can have more lines and to create more complexity for the dining table, as well as a larger working space. dining space. Okay. So this is the final build product. The marble is very thin. So even though we have the rattan substructure as well as the plastering, the total thickness of this particular table is 20 mm. And when you touch it and feel it, it feels like stone. It doesn't feel like laminate. It's cold like stone, like real stone. So again, this is another photo. So as I mentioned, right, so we have all these skills for like computational design, but this is in for the top 5% of society. So how can we use this for the masses? So when we, as I'm also a member of the Singapore Institute of Architects, Young Architects League, so we were invited to come up with a pavilion as part of this year's ArchiFest. So it's still ongoing from now till the end of September at URA Center. So for those of you who are nearby, like in JB, you all can drive down and come take a look. So this is a modular system because we want to think about the afterlife. So there are always a lot of exhibitions that architects and designers are invited to, but it's rarely thought about what is the afterlife of the exhibition. So there will be a lot of waste of materials. How can you reuse this? So what we came up with was a design that is modular and could also have a life after its finish, its initial responsibility as an exhibition. So this is just snippets of the Grasshopper script. We are able to quickly generate all these options by just using very simple elements like dividing a curve and then twisting the curve, and then using Grasshopper again to manage the amount of materials that we anticipate so that we can come up with the construction costs and the fabrication costs. So this is the fabrication facilities of a builder society. They are former architects who have become fabricators. So they are very cool because they also know how to use Rhino and Grasshopper. And we collaborated with them very closely to come up with this fabrication technique. So the wood is sustainably sourced birch wood that are laminated together. So it's 3 pieces of this birch wood ply laminated together. And they have a joint that will intersect each other. And thereafter that, we will bolt them in through from here. So the detailing is very clean, as you can see from the earlier, you will see from the later photos. And we have designed it in just 2 main modules. The squares themselves are all similar, but the 2 main modules are more towards the fact of how they are connected to each other using lines, using these strings. So this is the design development from the 26th August to 1st September because there were some deviations with the initial site dimensions because we have received some different plans from the curators. So even though we have already finished the construction, the fabrication, so when we came to site, we realized, oh, there's some slight deviation here. We can actually slot in our modules in between. And then we think about how we can make the whole walking experience even more interesting. That's why we came up with another proposal here. This is how it's fabricated. So this is good because it's very cheap and you use, again, kind of like the project that I shared earlier about the bricks. A complicated project can be simplified and can be executed without skilled labor or even without like very high-tech fabrication techniques. So we use a simple crimp to crimp the ends of the strings, and then you will just use a little lighter to burn off any excess that you have. Okay, and this is one of the mock-up here. And it's a final product now here. This is one of its first iterations. It's supposed to house the cross-crit between the institutes of higher learning in Singapore. So our two main universities with architecture, NUS and SUTD, as well as the polytechnics, will have their student works exhibited here and also have cross-crits. So they will come together and they will talk about their projects, and they will also critique each other. So it's a nice integration with our pavilion. And I'll just show you a little video to cap off about the whole process. So the builders are setting up the main frames, but what you see there are student volunteers who come in. We have this system where we already laser cut the locations of the points where we need to have the strings, and we just use it as like a template. So again, students from Ngee Poly. So it's a nice collaborative effort. So everybody come to build. So it's interesting because you see the students can experience something that they built from scratch. And they have to work together. So it's a nice relief from always designing from the computers. Okay. And these were our sponsors. So this video is done by another student volunteer, Choi Wei-Zi. Okay. So after all this long talk, right? So how this is just to tell you what are the softwares that has been used. So essentially what I have used in SUTD when I was part of the research lab was primarily Rhino and Grasshopper. I also teach at BC Academy. So we are sharing techniques of how you can use Revit and Dynamo together with what you see here is this symbol is for Ladybug. It's a plugin that is available both in Grasshopper as well as in Dynamo to be able to come up with environmental simulation case studies. So you can study, for example, the interior daylighting solutions, or you can also study the internal heat, as well as if you have another plugin called Butterfly, then you can also simulate the wind flow. And right now, right, there's a cross in the divide, so you no longer need to be in the camp of you use Rhino versus you use Revit, because there is this software called Rhino inside Revit that integrates both of these workflows together. Because most of us in the practice, right, especially in Singapore and I think Malaysia too, we use Revit a lot for BIM. In Singapore in particular, as long as you build a project that's more than 2,000 square meters, it's mandatory to use BIM. So no choice, everybody uses Revit. Okay, so this is the final slide. So I think just enough, 45 minutes. So I also have this YouTube channel together with BCA. BCA is the Building Construction Authority of Singapore, where we share case studies of the use of BIM in the construction industry. So not only will we invite academics to share their research, we also invite people from the engineering discipline, from the construction discipline, from contractors and fabricators to showcase what they have been using in terms of their workflows in their daily life as a practitioner inside the construction industry. So you can feel free to check out this channel. You can scan this QR code. Every time there is it's a monthly sharing session, and it's already now in its, I think, 9th or 10th month. We are planning to keep it going. So feel free to go and subscribe. Anyway, it's free. And yes, finally, this is my contact information here. This is my email. If you have any questions about how you want to think about using this kind of software for your own practice, you are welcome to come and ask. And especially if there's any young architects here who also want to join, we are also looking for new staff to join our practice. So you can also check out our website, and yes, can jump over to Singapore. Okay. That's it. Thank you very much, Siti.
Thank you very much. Talking about that, actually, in November, we are having a grads fair, something like a recruitment speed meeting kind of concept, where we collaborate with all the practitioners and also any creative industry to come over. And I want to say that it's like an interview session, a speed meeting kind of interview session, where we open to all our community and also our friends, students, especially the graduates who wants to find a job and internship. So that grad fair will be coming to them soon in November. So
in KL?
Yes. But we can also do an online kind of concept, because we are also open to any kind of practitioner of firms overseas. So it's kind of be like online and also physical interview session. But the candidates have to come physically to them. So maybe I will send you the invitations. Maybe you can join.
Yes.
All right.
Thank you.
Lovely. All right. So thank you very much for the sharing session. So I really enjoy it so much, because I'm looking forward to see more of your products, especially from your company. And I'm open to any question from the audience. Actually, we have a few questions here. First, from Muhammad Aizad. He asked, what is the material for Arches Vertical?
Oh, that one is steel. As I said, it's a rolled steel from Vietnam.
Rolled steel from.
Yeah. So they will roll the steel members, actual members, fully, and then after that we will clad it with again steel purlins, and the panels are in aluminium.
Any specific specification for the steel itself, type of steels and the thickness that can bend like that?
Oh, okay. Yeah. That one I cannot recall offhand. This project is 7 years ago. Yeah.
Oh, okay. It was quite some time. Because there's a lot of steels, and then not every steels, and you need certain type of thickness to go that direction. So you need that kind of information to be there. All right. I hopefully answer Muhammad Isaac question. The next one is anonymous attendees. How Rhino and Grasshopper is used in computational design, and which is better, Rhino or Grasshopper?
Oh, okay. No, so Grasshopper is a plugin inside of Rhino. So it's the same. So how is Rhino and Grasshopper used in computational design? It's kind of like, okay, if you see from my previous slide here, it's a very simple visual based linear kind of logic. So you have one connection to this, or you can have multiple connections to something. So this thing in here supposed to do something. So in this case, is supposed to multiply between these two numbers. So how it works is just to make the logic in a visual algorithm, into a visual algorithm, so that as designers, it's easier for us to make these kind of connections rather than taking the big jump to use Python. So the project that I showed you, the future of us, that one, it was coded in Python itself because of the complexity of it. So to summarize the question, the answer to the question, right? Rhino and Grasshopper can be used in this kind of way. You can use it to, like what I'm projecting here, to show how much material you need to use for your design. It can also be used to design for, like what you saw in the earlier examples, how we can optimize for the internal daylighting. So in one of the landed house, the Total house, we use Grasshopper to simulate the amount of heat as well as the wind flow.
I think it depends on the intention of your design, which
Right.
direction you want to go, then you have to use the suitable software that could complement it, right? Okay, and then I think hopefully that answer your questions. The next one is Henry Kong. Is there any recommendation software or tools for environmental analysis and record?
Oh, so yeah, the recommendation would be Ladybug, which I just showed just now, because it's free. It's free both when it's used inside of Grasshopper as well as when it's used inside Rabbit Dynamo.
You can also use the Butterfly. It's also free, right?
Yeah. Yes, Butterfly is also free.
Okay. All right. So I guess I answer your question, Mr. Henry. The next one is No Fatiha, No Rashid. Using visual programming is easy, but sometimes stumble upon the need to use coding. How do you teach yourself to learning coding?
Oh, okay. Yes. So for me, I never really learned coding. I was, as I mentioned just now, in one of my first few experiences, right? That one was with the Aspen Art Museum. So that time when I was studying in the States, right, they were developing this software called Generative Components for Bentley. Bentley, I think some of you would know that they have MicroStation, and it's widely used for infrastructural projects.
Yep.
So this was what I learned from the source itself, from the people who wrote the software. But in actual fact, right, once I learned this visual programming, which is generative components, when it comes to coding, most of it was self-learned. In fact, all of it is self-learned. And how you learn from yourself is that you just have to show yourself to do the thing that you need to do. So for example, for me, when I was an intern there, the supervisor just tell me, okay, this is the design. You have to make sure to generate it so that your German counterpart can do the physical model. So if you no choice, you have to figure out. So that time there was already Google, so you just Google, and I found out there's a forum. So I post my question on the forum, and then after that, people will come and tell me, oh, actually you should try it this way or the other way. And because it's like a problem solving way, right? After a while, you get so like happy with it that in the end, most of the times I'll also be on the forum itself. So even if I don't have a question to ask, I'll just read through what people are asking about other questions. Then from that way, you will also learn how to do things that you would have not thought of before. So to answer your question, right, to learn coding, the best way is to find a problem that you need to do and force yourself to learn it, and also to see other examples from other people who are maybe in the forums. Because there's especially for coding, right, there's multiple ways to get to your end product. You can, create like a function, or you have to create a class. It all depends on how you want to, how elegant the coding is.
I guess that's how you learn. You just need to throw yourself and don't be afraid to fail.
Yes, don't be scared. Yes.
Yeah, because that's the thing that I learned from myself. You have just throw yourself there. All right, hopefully that answer your question, Fatiha. And then the next one is, okay. How receptive is the public awareness, public towards this parametric design in domestic architecture? Do you find the application wide enough? Do your client normally approach you because of your parametric project, or it is more of you through proposing the design method whenever application? Yeah.
Okay, yes, yeah, that's a very good question. So, domestic architecture, never. So, most of them, they just want to have their house as soon as possible, as beautiful as possible, as cheap as possible. So, that's why you won't have that. But what we try to integrate is that we will tell them, after we get the job, that, okay, our solution, for example, if we were to propose vent blocks, ventilation blocks, if you place it at this particular facade, it will help in your cross ventilation. In future, you will not have to spend so much time to do air conditioning. Then you will save a lot of electricity and you'll save a lot of money. Because a lot of them, they are thinking more in terms of like, oh, maintenance and how much money they will spend. Not so much about the high arching, morals of sustainability and our earth. But for more commercial projects, it's easier also to show them. So like that, they did approach us because of our expertise, because they know that we can design very quickly and yet have a more landmark kind of design rather than the very simple design, and we can deliver. So that particular client came specifically because of that. Yeah. Okay.
All right. So hopefully that answer your question. Next one is Pei Chang Lee. How do you see the future of computational design in Singapore and Malaysia?
Okay, Malaysia, I don't know, but for Singapore, right? Okay, Singapore, our government is very specific, very regulated. So as I just mentioned, all projects more than 2,000 square meters need to have beam. So most of the practices in Singapore, except for small practices, would already be using BIM, as in building information modeling, in their design as well as construction management. But there is not a lot of computational design. And that's why, again, you can see I was showing you with the YouTube channel, the BCA approached me to do this kind of a sharing session as a host for other industry practitioners, so that it can increase the use of computational design. For Singapore, we really need to do it because we have not a lot of land and not a lot of manpower. So there is already a lot of users in, say, for example, our public housing, right? We use a lot of PVC. So it's a volumetric construction. It's like this giant module that is already made. Like it could be a toilet or it could be a household shelter that's already prefabricated and then hoisted and built. So this is already one element of using computational design to be able to quickly design this kind of modules and also do the concrete 3D printing for this kind of modules. So in Singapore, it's definitely very structured and driven by the government. I'm not so sure about Malaysia, but I think if you all can adopt it step by step and sell the idea, it will be good. Because at the end of the day, what I'm trying to show you with all these projects, right, it's not that you will build something very spectacular. Like the pavilion is SG50. So it's not every year that Singapore will celebrate and spend so much money to build this giant thing. So But if you use this technique to be able to make your own life easier, then it's much more useful for yourself. It could be for something very simple like the landed house facade, or even for the Ling Bridge.
It has to start somewhere, right?
Yeah, yes.
Okay. So the next question is, Ivan, how can I sign in? Sign in on what is it?
I don't know. Maybe for the points.
My point. I guess we will issue out the QR the code later. Sign in. You have to ask the. I think
that one is just subscribe. I think you can just subscribe to it.
Yeah.
The QR code.
This one, I think he's talking about sign in the first because he's a bit late, I guess.
Oh, okay.
Okay. Yeah. I'm not sure how to answer this. Maybe the management can help. All right. Next question is E-Kite. I say Gordon. Number one is computational design data dependent. How does it respond to the ever-changing built environment, example climate change? And then number two, any thought of machine learning in architecture?
Oh, yes. Yeah. Okay. Very good questions. So, of course, computational design is data dependent. There is really a lot of data that you can tap on. What I shown you earlier for the sensors that we use, it captures the three main data that I was reviewing: relative humidity, lighting levels, and temperature. So all of this information can be used for you to track your own building as well as your own environment. Currently, now I'm trying to also get a grant to do some research to create a sensor and a monitoring system, a very small one, ubiquitous, maybe just like this, smaller than your aircon remote, that everybody can plug into their own built environment. And this can give you suggestions of how you can improve the way in which you live, because it will basically be something like your Fitbit. It can track how your room is performing in terms of the natural daylighting as well as the temperature and the relative humidity. So this will bring me to the answer to the second question. So any thought of machine learning in architecture? Yes, because with a lot of data, you will need to use machine learning to understand this data, and then to pass through all this information to come up with the best solution. But of course, at the end of the day, it is important to still have the more human aspect to it. Whatever that the computer can suggest to you, like even say, for example, that table that I designed, the marble table, the computer generated many iterations. The most efficient iteration was not the one that was built, because the most efficient one may not be the most aesthetically appealing one. Okay, so my thoughts of machine learning is, yes, it's very important, but it's also very important to put the human factor into the final built product.
There's a risk to look into it, actually.
Yeah.
Okay, so the next question is Heng Huat Chu. What is the equipment or device that you use for wind and light measurement in the existing building or AA projects?
Oh, okay. So it's a on-set data logger. So that particular device is very small. It's something like this, and that particular logger can log, as I mentioned, for the three main things: humidity, temperature, and lighting levels. There's another one that is slightly bigger, that's called a weather station. It's also by Onset, O-N-S-E-T. That one costs a few $1,000 because it's supposed to be an outdoor weather station that takes in the wind values. It's supposed to be, be able to withstand storms and everything. You don't have to invest in that. I think the one that I've mentioned earlier, the first one, is enough, and it's less than $100. I think maybe $90 plus. It is very useful for you to be able to already see exactly what are the values before you design and after you design, so that you really validate what you have envisioned. And it's cheap because $90 gives you the hardware. It also comes with the HoboWare software. So this software allows you to graph all the information that the machine has logged for you. So I think that's good. I know of some other brands also that you can try, but those brands, they don't come with that software that I just mentioned. So you just have the hard Excel, CSV value files after the whole logging period.
I guess we need the data to
Yes,
come up with this.
it's just the raw data. Those
Yeah.
those cheaper ones only give you the raw data.
Actually, a lot of equipments and hardwares nowadays, they come up with the data. For example, like the one recently I just saw a driller for concrete. They can read the distance of the screw that coming into the concrete and whether there's any cracks in between. So
Yes.
this kind of data is really important when you do a structure designs or something like that. So you need to find in the market, and like normally I will go to the engineering exhibitions. You can see a lot of equipments and new technology on this information. So hopefully that answer your questions. The next one, I think this is the last one. Do we still have? Yeah. What is the criteria for working in Singapore? Oh, you already planned this.
The criteria for working in Singapore is I think there's two main working passes. It's either an employment pass or the work permit. So I think most architects should be coming under the employment pass. I have one colleague working with me now. She's on an employment pass. So employment pass, you will need to have a degree. I think it definitely has to be a bachelor's of architecture degree. And the best thing is if it's a recognized bachelor's of architecture or even a master's of architecture within the list. The Singapore Board of Architects has a list of recognized universities that you can take a look. So if your university is in that list, then you are definitely safe to come. Otherwise, even if your university is not on the list, I think as long as you have a bachelor's, then you will be able to fulfill the criteria.
Where we can get the information regarding the work permit?
Our Ministry of Manpower.
Ministry of Manpower. Probably I can help the new grads here. Okay. All right. Any more questions? Let me check. I think we have. Oh, we have one last one. Is it the last one? Gordon, any good intro of open source database software and plugin for human behavior simulations?
Example, okay.
Traffic
this one, this is not really in my expertise for human behavioral circulation. Because as you can see, my projects are mainly towards definitely fabrication and the environmental simulation. So about human behavioral circulation, I'm really not so sure. Yeah, sorry.
Yeah, it's something else.
Yes.
Or the last one. Can I continue practicing as an architect in Singapore if I have Australian architect license?
Oh, okay. Our BOA is quite strict. So if you cannot really call yourself an architect in Singapore unless you already have
the recognition
registered with the Singapore Board of Architects. So if you have another license, I'm not sure whether Australia is part of the. I know there's a regional architect thing for Singapore as well as the other countries in the region. But if Australia does not come under that, then what you will need to do is, firstly, you have to register your intent to be registered as an architect in the Board of Architects. They will review your application. If you have sufficient built experience, they will either ask you to do a test and an interview, or if you are very good, they will just ask you to come for an interview. And if you pass the interview, then you will be able to be registered as an architect and then practice officially as an architect in Singapore.
Yep. Okay, so maybe can contact Singapore Board of Architects to get further information on this.
Yes.
And all right, the last one is how can I? Oh no, right. This one is related to CPD point. So I think that's all. But I do have one question. I'm really looking into it. Actually, what is the key of this system could fail? The key factors that this system could fail? Because every time that we put some information and data and everything, you can have the information and generate the design. But what is the possible key factor that make this analysis could fail? Anything that you come through your experience?
Any thing that from my experience about sorry, come again.
For example, that you are doing these computational systems and everything, you could put in all the data information, you test the models and everything. But is there any possible element or a factor that could make this this model fail?
Or fail? Oh, okay, yes. So, yes, that's a very good question. In fact, what you need to do when you want to use computational design techniques is to frame your question properly first. So different projects have different emphasis. So like for example, for the furniture, the emphasis is just basically on the three main factors, how fast you can build it, how stable it is, and how much material. So you must frame it properly. If I frame the question instead of being these three elements, but like for example, something that is not relevant or correct in terms of the table, then of course the simulation will fail. If I want to test like the span of it, it sort of makes sense, but it will just make the whole project not so the whole analysis not so productive. Okay, so in essence, that's about framing the question, and it comes with experience. After a while, you need to have not only just computational skill to know coding, you also need to know like the more hands-on aspect of architecture and design, in terms of how you understand materials and how you understand design and planning. Yeah.
Okay, understand. All right, I think we still have time to answer another few questions just coming in. What happens if the material used in the construction damaged after a while? Example, the special design marble is broken, or how the client want to change. Sure, cannot simply order from the online shop, right?
Oh, yeah. If it's broke, I don't think it will break, because as we have said, right, it may crack, but the whole structure in itself, because of the double curvature, right, it's quite stable. And within itself, you can see that there is metal as well as the rattan shape. So it's kind of working almost like a RC kind of structure. So it will not break, but it may crack. And if it cracks, what they will do is they can actually send it back to the supplier. As I said, right, it's bending the marble over. So what they will do is they will probably bend another piece of marble, remove part of it, and then bend over, depending on which part is chipped. So I think it can be repaired, but it cannot be replaced.
But this question is already in your mind during the design stage, right? Just in case if damage and everything. It's not like afterthought kind of situations, right?
Yeah.
Yep. Okay, the last one. Have you ever used Dynamo? If so, what is what it is like to compare to Grasshopper?
Oh yes. So yes, I have used Dynamo. Dynamo, okay, to be frank, it's much more buggy than Grasshopper. If I were to compare it, it's like an analogy, right? Between the Apple ecosystem versus the Android ecosystem. So Dynamo is like, because Revit, a lot of people use Android. and then maybe Apple is less. But there is a lot of support for it. There's a lot of apps for it. So Grasshopper, as I mentioned, there's a lot of plugins. So it could be the ladybug and butterfly, and a lot of optimization plugins like Kangaroo, Karamba for structure, Sophistic for structure. Dynamo has less plugins and as compared to Grasshopper, but it is catching up now. And like I just mentioned, right, there is a Rhino inside Rabbit plugin. So it's essentially you can still use Grasshopper and do all this computational design within Rabbit. So you don't even need to use Dynamo anymore. You just use the Grasshopper, which has a much bigger forum that I mentioned than Dynamo. So easier to learn. Grasshopper easier to learn than Dynamo.
More user-friendly, I guess.
Yes, also more user-friendly.
Right. So hopefully that answer your question. Any more questions coming in? I guess, okay, I don't think I will see any. Oh yeah. Is Apple ecosystem suitable to work on digital provocation?
Oh, okay. Not so suitable. Because, okay, Rhino and Grasshopper still runs on Apple. That's correct. On the M1 Mac. But the thing is that when you want to go towards more of simulation, especially for computational fluid analysis, right? It's more Microsoft, and in fact, it's actually more the Windows shell as well as Linux based. So Apple is not so suitable for this kind of a more complex digital fabrication.
I guess you need to use something that can come up with the simulations better in order to make sure your design is answer all the objective of the early intention of the design. Then you will be more flexible to it. All right. Any other questions? I think we're already at 6:18.
Oh.
Yeah. I didn't realize that too. All right. Anything else you want to add in to our news to our audience here? I think should be okay. Do you have anything else? All right. So I guess that's all that we can wrap up today. And thank you for your time, Mr. Aloysius. We learned a lot from you today, and hope the knowledge that you share today would inspire and benefit our all young designers out there. And probably somebody will join your company.
Yes, hopefully.
So I would invite you to our grad fair. We will send you an email soon. And that's all from us in PAM. We hope to see you again in the next design lecture series. I'm Wan Siti Hajar Omar. Have a good evening. Thank you.
Okay.
Bye.
Bye.